Okay, so angles of elevation and depression.
The announcement started.
Stop. I want you to answer the review questions 1 through 4, if you would, please. These are tough questions, aren't they? So the measure of a right angle is blank than the measure of an acute angle. Greater than, right? And blank than the measure of an obtuse angle. What'd you put? Less. A right angle has a measure of 90 degrees. Lines that intersect to form 4 right angles are perpendicular. Circle the right angles in the figure. So angle ACB, is that right? BAD? Nope. ADB? Nope. CBA? Yes, there's one, finally. BAC? Nope. DBA? Yes. So our vocabulary for the word today is elevation. Elevation of an object is its height above a given level, such as eye level or sea level. So some places have an elevation that's below sea level, so they would have a negative elevation. Some places have an elevation above sea level. Like for instance, Prescott is a mile above sea level, so it likes to call itself the Mile High City. But what city would that be? Denver. Yeah. Take the notes. All right. So we're going to use what are called angles of elevation and depression here. So let's look at a little picture. We're all focusing. Here's you. And here's your eye level. This is your line of sight right here. If you have an angle of elevation, your line of sight is going to go from, oh wait, hang on, let me see if I can turn that up. There we go. So your line of sight is going to go from here to here if it's elevation, right? So you're going to go from here to here. Isn't that the coolest thing ever? Having so much fun with my technology. So elevation means it rises, so you look up. So we're going to put here, from here to here would be elevation. Well then, depression, and if you want to think about it, and I'm not trying to be funny, but people who are depressed, you tend to think of their heads are down, they're looking down, they don't want to, look at anybody, that kind of thing. So if somebody's depressed, an angle of depression would be going down from that line of sight. So we'd be going from here to here. So angle of depression would go from here to here. So both of them start from that line of sight. Normally your line of sight is from your eyes. Sometimes in our math problems, your line of sight will be at your toes. Weird but true. So if they don't mention how high your eyes are off the ground, you have to assume your eyeballs are at your toes. You're just staring at me like, huh? You'll see as we go through here in a minute. All right. Just go with it. So, okay. All right, so let's use our words of elevation. So John blanked his feet on a footstool. John, elevate, elevated, elevation.
Elevation.
John elevated. The blank of Mount McKinley is 20,320 feet. Elevation. Ian. You blanked an object by raising it to a higher position. Elevate. All right, so hey. All right, so most of what your problems today are going to be dealing specifically with word problems. And so you got a picture here What is a description of angle 2 as it relates to the situation shown? So as you can see right there, this is our line of sight, isn't it? And so angle 2 from the line of sight, is it going up or is it going down? It went up. So from here to here, does that make it an elevation or a depression? So this is an elevation. And look at the true-false questions. Angle 2 is above the horizontal line. True or false? True. So since it's above the horizontal line, and the horizontal line, that's your line of sight. And number 9, angle 2 is the angle of elevation from the person in the hot air balloon to the bird. Now that's interesting because an angle of elevation can turn to an angle of depression depending upon your perspective. So remember we were talking about angle of reference when we were doing our trig ratios. So if your angle of reference changes to the bird, for instance, or something else, then an angle of elevation can turn into depression. So is that true or false? It is true because that's what we were just talking about. We were saying that our line of sight is coming from the person in the balloon. And so since they're looking up towards the bird, that's an angle of elevation. Angle 2 is the angle of depression from the person in a hot air balloon to the bird. Well, obviously if 9 is true, what's 10? False. Number 11, angle 2 is the angle of elevation from the top of the mountain to the person in the hot air balloon. Well, let's look at the line of sight from the mountain. Oops. All right, so apparently I can have 2. Here's another one. Since I'm ambidextrous, and then I can make that one turn because, see, I've got skills. I just love technology. This is the best week ever. All right, so if this is my line of sight now.
I'm so sorry.
I know. Don't you feel sorry for me, little math teachers, that this is what is exciting? All right, so if this is a line of sight from the mountain, isn't it the same line of sight that the person has? Aren't they the same line of sight? Right? And so it's saying angle 2 is the elevation from the top of the mountain to the person in the hot air balloon. Is that angle 2 from here to here? From the top of the mountain to the person, isn't that just the line of sight? That's not even an angle, is it? I am stabbing. So this one's false because there's not even an angle that's created. There's no angle of elevation or depression. But what would be this angle from here to here that I'm creating here? Is that elevation or depression? Elevation. What about this one?
Depression.
Okay, so it's not so hard, right? What about angle 4 here? What's that an angle of? The line of sight's the dotted one.
Elevation.
So we're going from here to, oops, sorry, I got the second one in there. So we're going from here to here. Is that elevation or depression? That's elevation. What about angle 3? From here to here, we're going down, right? So that is depression. What about from the bird's point of view? What's angle 1? Depression. All right. So number 12, describe angle 2 as it relates to the situation shown. We already just said it was an angle of elevation, so you can put that in there if you want. From the person in the balloon to the bird. So then we come to problem number 2. You cite a rock climber on a cliff at a 32 angle of elevation. So they're telling you it's an angle of elevation. If they didn't draw the picture, you would draw the picture. So here you are, and they're telling you this is eye level, so that must mean that your eyeballs are here. So that's your eyeballs. And then you're looking, whoops, you're looking from here up. So there's your angle of elevation, is at that 32 degrees. Your eye level is 6 feet above the ground. So that means that we've actually got right here 6 feet. So I told you that they might mention how far you are above the ground. And so let's give yourself a head and a little teeny weeny body and some hair. So you were 6 feet. The 6 feet only goes from here to here. And you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? Well, this would be a distance of x right there. So once we find x, what would you have to do? You'd have to add 6 to your answer. So let's run through the problem below. So your angle of elevation is 32 degrees. Your distance to the cliff is 1,000 feet. And your eye level is 6 feet above the ground. Your need is the height of the climber from the ground. So that's going to be your x plus 6, right? Yeah, let's put the climber up there. So your climber's up here. Help! Maybe he does. Find the length of the leg opposite 32 degrees by using... Did they have to tell us tangent? So right here, this is side opposite to that 32 degrees, and isn't the 1,000 side adjacent. What do you know about this 1,000 here and this 1,000, or this ground distance here? Are they the same or different? They're the same. So if this is 1,000, this is 1,000. So those are parallel. So we are going to use tangent because we have opposite over adjacent. So we're going to do tangent of 32 degrees equals what? Opposite is x, adjacent is 1,000. And then they're just having here, we're going to add 6 feet onto x when we're done. So I'm assuming on the next page we're going to solve this. Is that true? Yep. Okay. So explain why you use tangent of 32 degrees and not sine or cosine. Because you have the ability to know that side opposite, right? Or at least you know part of it, and that's what you're trying to find. And then you're able to measure that ground distance. What you're not able to measure is that hypotenuse. That distance from you personally to the climber is that hypotenuse. So you are finding these side opposites, 32 degrees, and you know these side adjacent to 32 degrees, which is the tangent ratio. So we already came up with the formula, right? So if I were you, I would just put here. Put an arrow here. So didn't they just write the equation? And then we're going to put tangent of 32 over 1. Then what did they do? They cross multiplied, didn't they? And so I don't really like solve for D. You can put here cross multiply. But that's goes here. And then they went from here to here by using a calculator, right? So they did all the work for you. So they're using D. We used X. Is there any difference between X and D? Other than how they look, right? So the height from your eye level to the climber is about, and we're going to go to the nearest foot. So what's the nearest foot? 625 feet. The height of the rock climber from the ground is about 631. How did you get that? So 625 plus that 6 feet of eye level got you to that answer. So we're just using prior knowledge and talking about angles of depression and elevation, so it's really no different. So problem number 3. An airplane pilot sights a life raft at a 26-degree angle of depression. Well, here's the deal. These ones get a little confusing because I don't think I can move that one. Nope, hang on. Let me find the one I can move.
It's the one that's straight up.
That's weird. How did I get the one that... Oh, was that? Oh, there it goes.
This is the one that's straight up.
All right. I didn't realize that they were different. All right. So if this is my airplane's line of sight right here. So this is a line of sight to the airplane. Line of sight always is parallel to the ground. Always. Before they have an angle of depression or elevation. And so it's saying that the pilot sights a life craft at a 26-degree angle of depression. So from the pilot here down to the life raft, there's your angle of depression from here to here. The angle of depression is not, angle of depression is not here, right here. And that's the biggest mistake you're going to make on this problem. Your angle of depression is here. So we're going to put the 26 degrees right here. And that's the big piece. Now, if this line right here, this line of sight line and the ground are parallel, what do you know about this angle and this angle here? Yeah, so the raft now becomes, remember I said that the angle of elevation, the angle of depression will switch depending upon your point of reference. And so if I look at the raft here, the raft's line of sight is the ground, or technically the water, right? Because they're sitting right there in the water. And then when they look up, now they have a line of, or an angle of elevation. And that's the same angle of elevation as the airplane's angle of depression. Because what kind of angles are they to those two parallel lines? They're what? Not corresponding. Alternate interior angles, right? So there's your two parallel lines and there's your alternate interior angles. So anytime you have an angle of depression, you can always convert it to an angle of elevation. And then this whole thing from here to here to here, if I were to draw a box, so let's continue out this line of sight out to the raft and go down. What kind of shape do I have overall?
Rectangle.
A rectangle. And so I know a lot of things about that rectangle. That diagonal creates two right triangles, doesn't it? So that I can use my right triangle theory with sine, cosine, and tangent to help me solve it. And so I can either solve the upper triangle or the lower triangle. Typically, I'll transfer anything from the upper triangle to the lower triangle because we tend to think better with that lower triangle. And so then they go on to say the airplane's altitude means height, doesn't it? Is, Daniel, would you shut that door for me, please? Thank you. So the airplane's altitude is 3 kilometers, so 3 km. What is the airplane's horizontal distance d from the raft? So horizontal distance is ground distance, or in this case, water distance. And so we're going to name that d. So the two things that we know, I'm going to use this angle of elevation here instead of this one. So I'm going to use this angle of elevation, this altitude and this horizontal distance. So if this is going to be my angle of reference, this 26 degrees here, what is the 3 kilometers to the 26 degrees? So this is side opposite, and then what's the D to the 26 degrees? Adjacent. So is that sine, cosine, or tangent? So we're going to use tangent, and then how did they get 3 over D? Isn't that opposite over adjacent? So we're going to solve that. So you go ahead and solve that down below, and I'm going to solve it up here where you can't see it. Please show all work. Start with the original problem. Is there any need to add or subtract anything to our answer, like we did on the last one? Nope. When you get an answer, share it with those around you. It does not say, so if it doesn't say,
Is this to the nearest 10?
does it? Where?
Around 20.
Oh, down below, okay. Let me see your calculator. Is it for sure? Check the mode.
It's 3 divided by 226. So you just take the D to the 26.
Brody, why are you out of your chair, dear? Remember? I want you helping Zoe. Meshach doesn't need your help.
Zoe does.
It's Meshach's birthday. He doesn't need any help on his birthday. He's a whole year smarter. All right, so, right? Only as we get older, we just lose brain cells, so. All right, so what did you get? How far to the nearest 10th, question 21, is the airplane's horizontal distance from the raft? 6.2? What'd you get?
6.2.
Really? What's my... You did. 3.
What did you get?
Oh, did I put in, I put in, because I can't read my handwriting. How funny is that? I put in 28. Oopsie poopsies. It'd be helpful if I put in the right degree. 26. All right, so let me fix something. Give me a moment. All right, so now what did you get?
6.2. Do you have a spare?
All right, so I will agree with you. It is 6.2. It's helpful usually if you put the correct degree in there, right? Yeah, it's usually a help. All right, so yeah, I think I put 28 in there. That was a little off. So let's look at the problems that follow. questions that follow? All right, so perform your lesson check. 22 through 24. So the angle of elevation is formed above or below? Above. The angle of depression is below. The measure of an angle of elevation is equal to, greater than, or less than the measure of the angle of depression. Yeah. Well, remember that problem where we're looking at it where the raft with the plane, those are equal. That's what they're referring to. And so they are equal to. If you're looking at the same situation, but just opposite people on, that plane versus that raft. Obviously, if you're looking at two different things, like we had the first example where they had the umbrella with the bird, the hot air balloon with the bird and the mountain. Now those could be greater than or less than. So it's really not the best question. All right, so then this lesson check for error analysis. A homework question says that the angle of depression from the bottom of a house window to a ball on the ground, so they're not showing it, but here's the ball on the ground, is 20 degrees. At the right is your friend's sketch of the situation. Describe your friend's error. And so I want you to think about it, and I want you to talk about it with somebody. So talk about what the error is. All right, so let's discuss this. So if I have a line of sight,
Whoa.
is it blue? Supposed to be purple.
Is it?
Anyway, so here's the line of sight.
Anakin's back.
So it's, is that what Anakin says?
He's mean.
So your angle of depression is from here to here. What's the error?
The 20 degrees is
Didn't I warn you that that would be the biggest error that students make, is they put this 20 degrees here and it really belongs here. So be careful of that. And so that 20 degrees can also be put as what? The angle of what in reference to what? The angle of elevation of the what? The ball. So I can go ahead and change that 20 degrees to read down here, can't I? Because those are equal. And so if I were then, they didn't give us any information to solve this problem, but then we could solve the problem. So is the angle, 25, is the angle that your friend identified as the angle of depression formed by the horizontal and the line of sight? No. Is the correct angle of depression adjacent to or opposite the angle identified to your friend? It was adjacent to, right? Next door, touching, sharing a side. And then your friend's error was he put the angle from the house to the the diagonal line, I would say. The diagonal line to the ball rather than from the line of sight to the diagonal line to the ball. All right, so we're going to do a couple problems, if you don't have any questions on that.